A quick review on units. Units are going to be very important in all of your engineering classes. Many times, if you don't know where to start on a problem, if you look at units, it will lead you in the direction that you need to go. So you need to be very comfortable with units, and I would recommend always putting units all throughout the problem as you're working it to make sure you don't make any mistakes. So here in statics and strength, we have kilogram. Okay, so this is a mass, and this would be in our SI system. We have force. We get there. Force equals mass times acceleration, and in this instance, it'll be gravity as our acceleration, and we can get to newtons. We could use kilonewtons, okay? A kilonewton is a newton times 10 to the third. Okay, so you need to be comfortable going back and forth between these. We work with length, okay? We might use a millimeter. We might use meter. Again, it's a unit times 1,000 to go from millimeters to meters. If we're looking at the foot-pound second, we will not be using mass. We don't use pound mass in statics or strength. If you are given anything in pounds, then it is given as a force, okay? So just keep in mind there's a little tiny f there. The other unit that we use is Kips. And many of you may not have heard of a kip, but it's 1,000 pounds. So if I have 5,000 pound force that's pushing on something, it might just be easier to say it's 5 kip. Okay, again, you need to be comfortable going back and forth between these, and we'll talk about how to do conversions in just a minute. As far as length goes, okay, inches and feet. And there are 12 inches in 1 foot. Okay, so if we're doing conversions, and let's say that I have something and the length is 3.5 feet long, and I want to put that in inches, then I'm going to remember my conversion of inches to foot, inches to foot. So I have 3.5 feet. My conversion is 1 foot, 12 inches. So I have a ratio here. I've got feet on the top, so I'm going to need feet on the bottom. And I'm going to put 12 inches up here. So I'm left with the units of inches on the top. 3.5, 12 times, and that would give me 42 inches. So just make sure that you're setting up this ratio appropriately when you are doing unit conversions. If I am given something in kilograms, so like it's 100 kilograms, and that's my mass, well, we have to always convert mass into a force. Force equals mass times acceleration, and here our acceleration is gravity. So we are going to have 100 kilograms, 9.81 meters per second squared, and this gives us 981 newtons. Okay, keep in mind this is kilograms. That's what we need to use for the conversion. It gets those newtons. If I have 981 newtons and I want to convert it to kilonewtons, I realize we can go back up here and that 1,000 newtons equals 1 kilonewton. Okay, so that's going to be our ratio. If I have newtons on the top here, then I need to have newtons on the bottom. There are 1,000 newtons in 1 kilonewton. Okay. And if I divide this out, I get 0.981 kilonewtons because my newtons go away. Okay? If you are having any problems identifying if it's number one, a mass, a force, or a length, you might want to write these down on a 3x5 card. Force, length. Okay? And if you're having any problems doing unit conversions, please see a TA, go to the MLSC, but you need to get this taken care of as soon as possible.